Hello, Mr. Wong. This is FRQ number 3. Okay, so part A asks us to draw the free body diagram of the scenario here. So then part A. So then the forces here is going to be F, that's pointing this way to the box. FG, that's pointing downwards. And then FN, that is right here. And then FK, because it's going to be like that because you're going to try and go up the block and then friction will act against it. And Fn is like that at diagonal because the surface is like right here now. So then Fn would be like here. Part B. Part B asks to derive an expression for the contact force exerted on the block. So then the contact force exerted on the block by the surface is just basically Fn. So you need to solve for Fn. You know that net force. We'll look at the net force in the y direction, which is equal to m times ay. Ay in the scenario is 0 because you're not moving or accelerating like in the y-axis, you're not moving up or down, and then which is equal to 0. But we also know that net force in the y direction is equal to Fn minus Fgy minus Fy. And we know that Fg or Fy is being subtracted because for the way that this thing is pointing, if we like kind of like straighten it out, it would look like this, with Fy being like that. And we know that, and we see that F is being pointed downwards, so it'd be two forces pointing downwards and one force pointing upwards. So we know that, so we'll equal the two equations together, so it'll be Fn minus Fgy minus Fy is equal to 0, and we will isolate for Fn by adding Fgy and Fy to the other side. So it'll be Fn is equal to Fgy plus Fy. And then here, Fgy is equal to Fg cosine theta, and Fy is F sine theta. And we know that because if you look here in the diagram, Fg is like that, and Fgy is here, and Fgx is like right there. And then the angle, this angle theta is given, is the same as the angle there. So that makes Fgy adjacent over hypotenuse. And then here, the angle is the same as that angle. So that's why Fy would be sine. Actually, Fy. Okay. So we can expand those two. Fn is equal to mg cosine theta plus F sine theta. And then that's the equation for the contact force. Right. Part C. Part C asks us to develop an expression for the block's acceleration up the plane in the terms of the things that are given. So we will look in the net force in the x-axis. So the Fx is equal to max, and then we also know that Fx is equal to Fx minus Fk minus Fgx, and we're subtracting because it's trying to go upwards, so Fx is pushing it upwards, Fk is friction, so it acts against, and then the natural tendency for Fgx is to go downwards, so that's why it's subtracting. Right. And then we will equal the two equations together, so Fx minus Fk minus Fgx is equal to m times a, and then a is the same as, I'll just make a equal to ax. So then we will expand Fx to F cosine theta, then Fk expands to mu Fn, because we know that mu is equal to Fk all over Fn, and then to isolate for Fk, we just multiply Fn to both sides. So mu is equal to Fn, or sorry, mu times Fn is equal to fk. Fgx will turn into fg sine theta, and is all equal to ma. And then we can replace fn with what we found in part b. So we'll mg cosine theta plus f sine theta should be f cosine theta minus mu times mg cosine theta plus f sine theta minus fg sine theta is equal to ma. Here I would distribute the negative and the mu into the parentheses, so it would be f cosine theta minus mu mg cosine theta minus mu f sine theta minus fg, or fg is also equal to mg, so mg sine theta is equal to ma. And here I would divide m to isolate for a, so it would be f cosine theta minus mu mg cosine theta minus mu f sine theta minus mg sine theta all over m is equal to ma. And here, the m here will cancel out with the m with mu mg cosine theta, and it will cancel out with the m and mg sine theta, so it'll be f cosine theta minus mu f sine theta all over m minus mu g cosine theta minus g sine theta is equal to a. And then I would factor out the g from the mu g cosine theta and the g sine theta. So a would equal to f cosine theta minus mu f sine theta all over m minus g times mu cosine theta minus sine theta. All right, that's part C. Part D asks for an expression for the magnitude of force that will allow the block to slide up the plane with a constant velocity. So since it's moving at a constant velocity, we know that the acceleration would be 0. So net force in the x direction is going to be equal to max, which is equal to 0. And then we also know that net force in the x direction is equal to fx minus fk minus fgx, and it will equal the two together. So it'll be 0 is equal to fx minus fk minus fgx. And then we will isolate for fk by adding fgx and fk to the other side. So it'll be fk plus fgx is equal to fx. And then we would break or expand all three of them. So the fx is equal to f cosine theta, which is equal to fk, we know is equal to mu times mg cosine theta plus f sine theta plus, and fgx is mg sine theta. And then here I would distribute mu, so it would be f cosine theta is equal to mu mg cosine theta plus mu f sine theta plus mg sine theta. Right. So from here, I would basically combine like terms by moving the mu f sine theta to the other side by subtracting it to both sides. So it would be f cosine theta minus mu f sine theta is equal to mu mg cosine theta plus mg sine theta. So from here, I would factor out an f from the left side. So it'd be f times cosine theta minus mu sine theta is equal to, and here I will factor out an mg. So it'll be mg times mu cosine theta plus sine theta. And then here I would isolate for f by dividing cosine theta minus mu sine theta to both sides. So it'd be f is equal to mg mu cosine theta plus sine theta all over cosine theta minus mu sine theta. Okay. Part D also asks for the relation that theta and mu have to have in order for the solution to be physically meaningful. So all that means is that for this to work, your denominator just has to be greater than 0 for f. So it'd be cosine theta minus mu sine theta is greater than 0. And I would just isolate for mu. So I would just do cosine theta is less than mu sine theta. I would divide cosine over and then mu over. So it'd be 1 over mu is less than sine theta all over cosine theta, which will turn into tangent theta. And then I would flip that, and I'll flip the sign. Mu is then cotangent theta. So then that's the relation that must occur. Right. Part E. So part E gives us values, and it just asks us to calculate the force F required to accelerate the block up the ramp at a constant rate of 0.5 meters per second squared. So then here we have to basically kind of like resolve for the whole equation again because of, yeah. So you know that net force X is equal to Fx minus Fk minus Fgx. We know that net force in the x direction is equal to max. And then here we know in the previous equation we solved for the equation for ax in part, what was it, in part C. So I would just copy this over. So yeah, copy. So you know that A is equal to, paste, to that. So then that I'll just plug in values. So it'll be 0.5 is equal to f cosine theta is given to be 20 minus mu is given to be 0.33, 0.33 times f times sine theta, where theta is given to be 20 all over m is 2 minus 9.8 times 0.33 times cosine 20 minus sine 20. And then we would be 0.5 is equal to, that would equal to, let me see, cosine 20 minus sine 0.3 times sine 20 divided by 2. So 0.468 minus, wait, that is wrong. I plugged in my calculator wrong, sorry. Now that, sorry, cosine 20 minus 0.33 times sine 20 divided by 2. Oh, it should be 4.413, and then minus f, which is minus, that is equal to 9.8 times 0.33 times cosine 20 minus sine 20 is equal to to 6.39, and I would add over it to the other side. So 6.39 plus 0.5, 6.89 is equal to 0.413f, and then so for f, I would divide 0.413 over it, so 6.89 divided by 0.413, and then f is equal to 16.68 n. And then it asks us calculate the force required, and then yeah, newtons. Oh yeah, I realized a mistake in my work in part A, or not part A, in part C. It's supposed to be plus sine theta because when I factor it out, I factor out a negative g, which makes this part, the answer part B, positive, and which gives you these values. Part F, the scenario changes. So now there's a second block here, block before M that is in contact with block M, and then we need to derive an expression for the first F that requires the system to be motionless. Okay, so here I would look at it as like the two blocks as one system. So yeah, so then I would just, as a prerequisite, I'd have big M is equal to M plus 4M, which is equal to 5M. And this is just to signify that is like one big block. I'm just going to look at it as one big block. Okay, so we know that the net force of the system is equal to MAX, which is equal to 0, because we know that we need to find it where the system is motionless, so the acceleration is just 0. So we know that net force system is equal to Fx minus Fk of the whole thing minus Fgx of the whole thing. So we equal the two equations together, should be Fx minus Fkm minus Fgx. And I would isolate for Fx, so I would move over the Fkm and Fgx to the other side. So Fx is equal to Fk big M plus Fgx big M. Right. And I would just expand all of them. So we F cosine theta is equal to mu Fn plus Fgm times times sine theta. And then Fn in this scenario, just like in the previous problems, it would equal to big M g cosine theta plus F sine theta. Because the way the force is being pushed is the same. It's just that there's another block. So everything's basically the same except there's going to be more mass, essentially. So we'll replace Fn with that. So F cosine theta is equal to mu times mg cosine, or that should be big mg cosine theta plus F sine theta plus big mg sine theta. And here I'll distribute the mu into the parentheses. So it'll be F cosine theta is equal to mu big mg cosine theta plus mu F sine theta plus mg sine theta. Wait, here I would move over the mu F sine theta to the other side. So it'd be F cosine theta minus mu F sine theta is equal to mu mg cosine theta plus mg sine theta. Here I would just factor out f on the left side, so it'd be f times cosine theta minus mu f mu sine theta is equal to mu mg cosine theta plus mg sine theta. And I'll just isolate for f by dividing both sides by cosine theta minus mu sine theta. So f is equal to mu mg cosine theta plus mg sine theta all over cosine theta minus mu sine theta. And here I replace big M with 5M, so f is equal to mu times 5M g times cosine theta plus 5M g sine theta all over cosine theta minus mu sine theta. In the top, I would just factor out a 5mg. Mu cosine theta plus sine theta all over cosine theta minus mu k sine theta. Right. That's part F. Right, part G. Part G asks us to we're given values and need to calculate the force F required to accelerate the blocks up the ramp at a constant rate of 0.5. Right. So I will once again look at it as one block. So the net force in the x direction is equal to big M AX. It is also equal to Fx minus Fk big M minus Fgx big M. Equal to 2 together, so the MAX is equal to Fx minus Fk big M minus Fgx M. Right. So here I would expand all the terms is equal to F cosine theta minus mu mg cosine theta plus mu k f sine theta minus mg sine theta. And then we established in the previous problems that that's what fk is and that's what fgx is. Here, I would just distribute the negative into the parentheses, so we get ma is equal to f cosine theta minus mu big mg cosine theta minus mu, that's not supposed to be k, it's supposed to be mu f sine theta minus mg sine theta. Here, I would move over the mu mg cosine theta and the mg sine theta. So it'd be ma plus plus mu mg cosine theta plus mg sine theta is equal to f cosine theta minus mu f sine theta. Here, I would just factor out an f on the right side, ma plus mu mg cosine theta plus mg sine theta is equal to f times cosine theta minus mu sine theta. Here I would divide both sides by cosine theta minus mu sine theta to ask for f. So f is equal to ma plus mu mg cosine theta plus mg sine theta all over cosine theta minus mu sine theta. And here I replace all the m's with 5m, or 5 lowercase m, so it'd be 5 lowercase m times a plus mu times 5m times g cosine theta plus 5m g sine theta all over cosine theta minus mu sine theta. I'll put in the values of 2, theta is 20, and mu is 0.33. So f is equal to 5 times 2 times 0.5 plus 0.33 times 10, because 5 times 2 is 10, times 9.8 times cosine 20 plus 10 again, because 5 times n, 9.8 sine 20 divided by cosine 20 minus 0.33 times sine 20. And that would equal to 83.333 newtons. And here, we were to calculate the angle of this, or yeah, it will be, if you know that the angle is, oh, it'll be like, kind of like, relative to the box, it'll be 20 degrees uh, southeast to the box. Okay, that was part G, right? H asks to calculate the magnitude of contact force between block M and 4M. So here I would just look at the 4M box because that one has less forces acting on it. So it would be net force in the x direction of 4M is equal to 4M times AX. But we also know that the net force of that box is equal to the contact force from provided from M to 4M minus the friction of that box minus FGX of that box. Right. Here, and that was equal to two equations together. So 4M AX is equal to FM contact minus FK 4M minus FGX 4M. And I would just expand them out. So the 4M AX is equal to FM, so 4M minus mu K 4 or times Fn 4M minus 4mg sine theta. And then in this scenario, Fn, or for this box, Fn is equal to Fg, Fgy over 4m. Because on that box, 4m, there's like no force being applied to it, because this F here is only being applied to that M box. So for 4m in the y-axis, there's no other force acting on it. So that would be equal to 4 is equal to Fg 4m times cosine theta, which is equal to 4mg cosine theta. So we can replace Fn in here. 4max is equal to Fm 4m minus mu. It's supposed to be mu only. Mu times 4mg cosine theta minus 4mg sine theta. Here, I'll just move everything to the one side that I say for the contact force. So before max plus mu 4 times m times g cosine theta plus 4 mg sine theta is equal to Fm 4m. And then from there, I'll just plug in the values that are given. So 4 times 2 times 0.5 plus 0.33 times 4 times 2 times 9.8 times cosine 20 plus 4 plus 2 times 2, sorry, times 9.8 times sine 20 is equal to contact 4m. And that So that it would equal to 55.12 and that's for magnitude, so direction, no direction. Right. Part I. Part I is basically as physics student, it claims that switching the order of the blocks does not affect the magnitude of the contact force between the blocks because the total mass of the system remains unchanged. Do you agree or disagree? So all it is saying that basically now this is 4m and that's just m. It's saying that the contact force is does not affect it, and I would disagree. And that's because originally you had it as m and 4m, and then for m is pushing 4m, and because it's you have a smaller mass pushing a bigger mass, that means your contact force has to be pretty big. But now since the roles are reversed, 4m is in place first, and then m is being pushed, that means that you would need a lesser force to push it. So the the contact force will change. So the student is wrong, and I disagree.